Remember when Inside the Magic School Bus shrank down and flew into Arnold? Yeah, science is actually doing that. The future is now! Hey there, bags of meat and water. Trace here for D-News. Thanks for watching. Giant feats of engineering, like space vehicles, dams, skyscrapers, and massive airplanes are complex, to be sure, but at least the engineers working on them can see what they're working on. Imagine engineering a pump, which is only a single molecule in size. Yeah, it's really hard. But a team from Northwestern University did it earlier this year. In nature, molecules are constantly moving around in our bodies, transporting energy, oxygen, and even information from one place to another. This molecular pump is a rudimentary synthetic copy of something nature does all the time. The pump uses a dumbbell-shaped molecule and a set of positively charged molecular rings, sort of like two magnets repelling each other. The rings then provide tiny amounts of energy that the synthetic molecule can use to make a pump ratchet at a predictable rate. The problem with nanotechnology has always been powering these itty-bitty little things, and realizing that they can harvest energy from nanoscale rings is pretty huge, or I guess it's kind of small. You know what I mean. They're hoping if they can improve the tech and capture more rings, they'd have enough energy to power artificial muscles or even whole nano machines. The development of nanotechnology has been steadily climbing over the last 40 years. With leaps like this, things are starting to get a little crazy. In 2004, scientists at New York University created a nanobot that bipedally walks on legs 10 nanometers long by adding a molecule called sorolin, found in the seeds of celery, parsley, citrus fruits, and the common fig. A few years later, a study on the future of nanomaterials said that we're only like 20 years, maybe 10 years away from a nano-sized factory. This sorolin molecule lets the nanobot walk along a DNA strand. The researchers envision this has the beginnings of a nanobot conveyor belt for nano-assembly. Think about the coolness of a nano-sized car auto factory. Assembling nanobots for any imaginable purpose. The NIH says that nanocomputers and nanobots could revolutionize the medical industry by creating nanobots which could mechanically reverse plaque buildup in arteries, or prepare tissues for cryonic storage, repair spinal damage, rewrite individual bases in our DNA, improve the efficiency of our cells, or map the complicated connections of the mammalian brain. Some of these things, by the way, they're already doing. And things are moving real fast in this, y'all. In 1998, researchers hypothetically designed a red blood cell that was 200 times more efficient than our regular red blood cells. It was, in essence, an atomic-sized oxygen tank that could fill up in the lungs and then distribute oxygen to the tissues way better than our own cells can. If that sounds far-fetched, take this one for a spin. Papers in the journal ACS Nano and Physics Today, among many others from the last couple of years, use what researchers are calling DNA origami to carry medication directly to cancer cells. DNA origami is essentially a nano-engineered barrel that can carry drugs or information to a specific place and then release it. Nanotechnology is getting better and better and better. But you know what else is getting better? Toyota. Toyota has been doing some tinkering of their own with the TRD line of Toyota trucks, enhanced to rule the off-road. So what's going to happen to nanotechnology in another 10 years? Go down into the comments, let us know. Also subscribe so you get more D-News. And if you haven't yet, go nominate us for a Streamy Award. We would love it. It would be great. It would be great for everybody. Spread that science around. Thanks for watching. We'll see you later.